There's a GCSE Maths video then on working out gradients and the gradient of a line. So a gradient is a measure of how steep the line is. So you can see here this one's steeper than this one, so A has a bigger gradient than B. Loads of different ways to work out the gradient. To calculate the gradient, you can find the difference in the y coordinates all over the difference in the x coordinates. That's y2 take away y1 all over x2 minus x1. We might have a wee video example of that a little bit later on. All lines that slope up, going this way here, have a positive gradient. All lines that slope down have a negative gradient. Horizontal lines have a gradient of 0. Vertical lines have a gradient of infinity. If two lines are parallel, then their gradients are going to be the same. So say you have two going up like that, they'll have the same gradient. If two lines are perpendicular, then the product of their gradients is -1. That's a wee bit of a tough one, but say you have two perpendicular lines and the gradient of one of them is 3, the gradient of the other one then is then going to be -1/3. It's like the negative reciprocal, if that makes sense. So that's the way you would work it out. The other one that I would want to add, and this is one of my favorite methods for working out gradient, is the gradient is the steepness of the line. It is how many squares you go up for every one that you go across. It's how many squares you go up for every one that you go across, and it's always across one and across one to the right in the normal sense, and that helps you work out the gradient then as well. So let's take a look at these examples and see if we can suss them out. We're going to do the y2 minus y1 method to start with here, but hopefully you'll be able to see then what goes on. So we simply need to pick a couple of points on this. So in this one here, I'm going to pick here, I'm going to pick here, and we'll get those two coordinates. So call this line 1. I'll maybe go a wee bit quicker for the other ones, but the gradient, which is m, is y2 minus y1 all over x2 minus x1, and my 2 points in this case are, it's a 0.15, so I'm going to call that coordinate 1, and then the point -3, 1. So my y2 is 1 minus 5 all over x2, which is -3 minus 1. Hopefully you can see where I'm getting those from. Your y coordinate here is the second one, so there, take away that, and so on. That gives me 1, take away is -4, and -4 divided by -4 just gives me 1. I can see straight away the gradient of this line is 1. You can see every time you go across one square, you're going up one square, across one, up one, across one, up one, across one, up one, across one, up one. But it's just to show that both methods works, and it won't always be as easy to read off that it's across one, up one. So sometimes this is a decent method then to use as well. Let's go for this one then as number 2, and we'll pick a couple of points. The only points really we can pick in this particular one are this one and this one. The other ones are kind of wee half coordinates and be kind of messy. So let's pick those two and we'll see how we go. M equals y2 minus y1 all over x2 minus x1. This coordinate here I call coordinate 1, that's the 0.43. Doesn't matter which one's 1 and which one's 2 in this particular case, as long as you're consistent. And then that's a 0.3 minus 5. So substituting these in then, y2 minus 5 minus 3 all over 3, take away 4. Something's gone wrong. Where have I gone wrong? That's the 0.4 across 3 up, that's the 0.3 minus 5, and it's y2 minus y, it hasn't gone wrong, sorry, I'm losing my mind. Minus 5 minus 3 is minus 8, 3 minus 4 is minus 1, and so the gradient then is 8. Sorry about that. I thought it was coming out as a minus and I could see that it was going up, so it was definitely a positive. Anyway, the gradients are 8. Again, I can see that's going to be an 8, because if you go across one square, you're going up the 8 squares, so it's a steepness of 8. Anytime you go across 1, the amount of squares you go up tells you the gradient. Okay. Number 3 then, we're calling this one number 3. With a couple of different points, we could pick this one, this one, this one, or this one. I'm just going to pick both ends. and we'll put our two coordinates in. So that's the point -5, -1. You can't see it, but I'm just writing it out here, don't worry about that. That then is the point 1, -4. And so let's sub the numbers in. If we call that number 1, call that number 2, m equals y2 minus y1 all over x2 minus x1. So we have y2, which is -4 minus -1, and then x2, which is 1, then minus -5. A lot of minuses to deal with here, so that's going to be -3 on the top because it's -4 plus 1. 1 minus -5 is 6, and so our gradient then, whenever you cancel it down, is going to be -1/2. Again, my wee plan always works. Every time you go across one, you're going down 1/2. So you can see across one, down 1/2, across one, down 1/2, across one, down 1/2. And that works. The way some people think about it is rise over run. So you're going to cross 2 and down 1. So rise over run. The rise is -1, so -1 on the top, and the run is then 2 on the bottom. So that's a wee way then of kind of working that out as well. Find the gradient of the line joining the points -3, 5 and -1, 1. Just the same format really as before. So 1 and 2. Gradient is y2 minus y1 all over x2 minus x1. My y2 is 1. Take away 5 all over -1 minus -3. 1 take away 5 is -4. -1 minus -3 is the same as -1 plus 3. So that's going to be 2. So a gradient then of -2. Find the gradient of a line which is perpendicular to the line joining the points 7, 4 and 1, 3. So we need to find that kind of the products are -1 or the negative reciprocal, but we need to find the gradient here first. So we're just going to do exactly what we did in the previous example and then find that. So our m is y2 minus y1 all over x2 minus x1. I'm calling this coordinate 1, I'm calling this coordinate 2. So we're going to have 3 take away 4 all over 1 take away 7. 3 take away 4 is -1 all over -6. So that's a gradient then of a 6th. Therefore, gradient of the perpendicular will equal, so it's a -1 over that, so it's a -6.